So this week I just gave more thought to why I can't get Pure Pursuit to run, where it seems to run on the simulator relatively well, but on my vehicle it doesn't run, and I wasn't sure why. And so finally last night I fired it up and decided to do some hacking on the code. And what I did, I took the one what was called know how, or whatever that newer one's called. I took that code and I thought, well, I'll mer I'll merge Al's extra data output. He's got a function that'll output a whole bunch of values to an array, and then you pull it up in Plot Juggler. Then you've got all those things there available that you can use. So I went through the first thing. I started modifying that, and I dropped the code in, tried to compile it. It wouldn't compile. And after about an hour, I thought, I probably shouldn't have done it this way. I probably just should have stuck with the old stuff and tried to get that. Since it was all merged together, I should have done that. But I was far enough down the path. I finished it up and got that newer version that where they tried to taking out the KDL stuff and just did basic geometry to make it work. So I've got that running, and I've got the Al's little function that puts out um, all the extra values, so I can see those. So I was playing around, and I don't remember what order I did this in. At one point, I went in and I want to see, does the rotational velocity that's created, because they put out a command velocity that contains rotational velocity, and then they also put out an Ackermann command that contains a steering angle. And when I look at it, I see absolutely no reason why what they've done should create a valid steering angle. So I was thinking, well, what if I go back and look at the rotational velocity that they generated? So I just simply plotted those two together. And what always amazes me, all this stuff, everything I plot out looks the same. And whether it's you're looking at the off path error, or you're looking at the steering angle, or you're looking at the rotational velocity, I can't really see a lot of difference between those. So I don't know, what they're expecting to get out of it. So anyway, what was my point on that? So I looked at that and decided that it didn't look significantly different. It just seemed to be like a scale factor of one to the other. And it could be that if I knew what I was looking at and zoomed in far enough, I could see what the actual difference is between the two. So anyway, I decided that wasn't the solution. So I moved on. And at one point I thought, if I just take instead of doing the calculations they're doing, if I just take the vehicle, and if you look at the screen, it's got on the vehicle, your x-axis is pointed out the front. And if you extend that out, that's basically a pointer that's pointing to your path pose you're trying to get to. So I thought, well, if I take an angle between base link and the path location, and then compare that to the angle of the vehicle, so it's the x-axis. If I compare that angle, as you turn towards it, that angle should drop down to 0 if the vehicle's pointed right at the destination point. So that, well, I'll look into that. So I tried plotting that out, and the newer code has something called D underbar ya, and it's somehow is saying taking an X and a Y and take an arctangent of that to get that value. When I plotted that out, that was acting just as stupid as everything else was. And I went back and looked at it and realized, oh, he's taken that from that in the code. They say do a lookup, or do a transform between the target point and base link, and that's where it's coming up with these weird numbers. I can't quite figure out what they're doing, but he was taking those values and doing something with the angle. So again, I'm not sure that's really what I wanted. So I went back and looked a little harder and figured out, how do I get the actual base link to point. And I got that to work, and that gives me a nice stable line on the screen of where, as you're pointing at it or away from it, that seems to work better. And but yeah, I can see it, but I haven't really done anything with that. I kept thinking, well, if instead of going through all these calculations with the transform and taking the sideways error and trying to somehow make a steering angle out of that, because he doesn't have anything, there doesn't seem to be anything in code that says base link is here and it's like, say, 1 to 2 to say 3 meters away from this point. That never gets included. So the only thing you're including is how far off the line you are, either to the right or the left. And it doesn't seem like that's enough information to generate a valid generate a valid path from that. So I got it that far and didn't do much more with it other than plot it. And then at one point I was looking at the I got tired. Every time I'd start this up, one of the steps was I'd have to fire the whole thing up and run it, and then I'd go back to plot juggler to look at the bag file. And in there, in order to look at the odometry heading, so I can just pull up the odometry and you go down to, it says what, pose, orientation. And then under that, it's got pitch, roll, and yaw. And then it's got pitch degrees, pitch, roll, pitch, yaw. No, actually it's got a quaternion, and then it's got this extra thing in degrees. But I always had to convert that. So I had to go through the extra steps in plot juggler and say, convert this quaternion to RPY. And when I would do that, it just took, it's like 6 or 7 more steps. I just got tired of doing that. So I'll just go into the code and have it convert that, and then output that in that lookahead array. So I've got that value already converted. I can just click on it and say plot that. And what I did, it turns out that, well, that really looks stupid. I didn't understand why. So let me go to so bad I can screw this up today. Go to screen 1. And assuming you can see that, this is what I just plotted to Slack this morning. And on the left side, let's see, you should be able to see my cursor. So on the left side, this is the one, this is the bad looking one. On the right is the one that I fixed. So if we look at the one on the left, do that, you notice that it looks, here, let's kind of back us off a little. So what you're seeing here in the upper hand, get the labels here. So the green line is the heading from the IMU, or it's the heading from IMU. This is actually an output of the odom, of the GPS to odom program. And this is, I think, is something Al put in at one time because he wanted to see what the heading was doing. And so that program takes in the heading from the IMU. So I'm just using the simulated heading from Gazebo, and I take that value, which is a quaternion that gives you your angle, and feed it into the GPS to odom program, and it will then, that are we still on?
Yes, we're still on.
My lights just flickered really bad, and my screen just went blank, so I didn't know if I'd lost it or not. So as I said, so that GPS to odom program, number one, it subscribes to the GPS fix, and so it gets latitude and longitude into the program. It converts that to your XY offset, and will put that information into your odometry message and your transform. And then it also subscribes to the IMU and pulls that in and takes that information, puts that into your odom topic, and puts that into your transform when it gets published. And then it's got that extra thing that it internally, it converts that heading quaternion from the IMU into that thing that says heading from IMU data. So that's what the green line is. That's basically what if that should be a valid value at coming out of that conversion program. And the other thing, the bottom one here says odom pose orientation yaw. I didn't want to do that. So this is the odom statement itself that's being published out to the outside world. And I wanted to know, does basically the data coming out of the GPS to odom program, does that heading here match the heading that I'm publishing on odometry? And if we go look at that, it does mostly. So here you got the green and the green and purple line. So the green and purple line, they're supposed to be right on top of each other, and they're not for some reason, and I haven't tracked that one down. But I noticed when I converted the when it went internally, I converted it. So internally in the Pure Pursuit program, they subscribe to odometry topic, and every time an odometry message is published, it goes to a callback. Let's see, could I quickly pull it up? No, probably not. Anyway, it goes to a callback, and the first thing it does, it just ignores that odometry message. It just uses that to trigger it. And then they've got a line that says, this is actually the, how do I scroll this? little bit. They got a line in there that says robot and map. It says do a lookup transform between your map frame and your robot frame, which happens to be baselink. And then it says ROS time 0. So I figured it was something to do with this ROS time. Anyway, they run this lookup and that returns back the thing that in our case should be identical to the odom message. And the reason I say it'd be identical because we're publishing the odom message in that GPS to odom program. It is just simply saying take the incoming heading and build the message from odom to baselink and publishes that. But in the real world, if you're trying to run something extra, if you have something else between map and baselink, you will have I was confused for a second there. You'll have anything that happens between map and baselink needs to be accounted for. So if you're running indoors and you're running AMCL to do your localization based on your walls and your laser scans and so forth, what that does, that nudges your odom marker around. So you have to be able to account for that. And if I just simply take the message that I was publishing through odom, which isn't the same as wheel odom, but that's what we're using it for. If you don't put in that extra transform between map and odom, what it will do is you'll just lose that and it's not going to work. But what we're doing right now, we're just mapping odom on top of map. We're blatantly putting it on top of it, leaving it there. And at the other end, we're mapping baselink on top of base footprint. So essentially the stuff coming out in that odom topic is going to should match exactly what you would do if you look up the transform between map and baselink. And it turns out if you run this command here that says do a lookup transform between map and baselink, and then this whole thing about ROS time, that was the clue, because I went and looked at this stuff and I see this orange line again should be right on top of these other two, and it's got this jagged effect. And I kept looking at it thinking, what is causing that? And it turns out if you look at it, see like right here in this section right here, this whole line here is like one sample time later than the data that came in. And occasionally it picks up a point that's right on top. So this particular data point right here happens to be right on top of where that's where it should be. They should all be right there. And then down here, it did it again. And see over here, just every once in a while it does that. It puts in a point that's where it's supposed to be, and everything else, then it happens to be one sample time later. So I started looking at that and their code, which says do the lookup transform from map to baselink, and that says ROS time 0. So if you go look this up, it says if you put in ROS time 0, that will take the latest, the most recent available transform and use that. And it looks like what it's doing for some reason, the two are published close enough together that occasionally one of them hasn't updated yet. So I played with that some more, and I came over, let me zoom out. So I attempted to fix it, and I went into that same statement and I modified it to do this. The whole thing looks the same, except it comes out, instead of saying ROS time 0, you say ROS time now. So it takes whatever your current wall time is and says, I must have that one. And if you run that, that will fail on you, because if it's not immediately available, it just fails and doesn't do anything. So they give you you add a new field that says duration, and that gives you so I think this says wait up to 1 second for the valid transform to show up. So when I did that, so I'm not exactly sure why the transform and the odom aren't showing up at the same time, because I published them both at the same time in that program. Now it could be one's got more overhead as far as how long it takes before it shows up. So after I did this, I told it, instead of saying ROS time 0, it says ROS time now. So it's going to take the immediate time. And then it says, but if it's not available, wait up to 1 second. And when I ran that, it does indeed fix the problem. Or it gets rid of the little jagged spots that were in there. So instead of jumping back over this line occasionally, I get a nice smooth line that follows it. The only problem is we seem to be like one sample time too late now, one sample time later. And I finally decided that probably doesn't matter because when you pull this transform in, it's got both your XY location and your orientation all merged together in that one message. So if it shows up a little late, I don't think that's going to be a major problem. So it took me forever to figure out, why it was doing. I wouldn't even have noticed it, except I got so lazy. I didn't want to keep converting that every time I called up plot juggler. So I just wrote the code that says, wrote the code that says, do this translation internally in pure pursuit and dump that out as a value. And that's what I noticed, that it was giving me a stupid looking line like that. And first of all, I thought, well, that seems odd. Why is it doing that? So after a lot of tracking down, I said, that's what's happening, is that sometimes it grabs the current um, transform location, and sometimes it's off by one. So sometimes it's one too late, and sometimes it's right on top of where it's supposed to be. So after I got all that figured out, it's looking like this now. That didn't, when I went and ran it on the simulator and the RViz and all that stuff, it didn't fix the problem completely. So this turns out it wasn't the answer, but that's something stupid that was happening that I didn't know. I've never really played with the transforms and the transform lookup and all that stuff before. And I see why they're doing the transform from map to base link, but I see that it's also causing this problem. So I don't know what people in the real world do about that. If they just ignore it, or um, it should have been obvious to me how to fix that. I don't know. So anyway, that was one of the things I did. And as I say, I went through and figured out, I got the point. So I know the angle between, say, the vehicle heading and a direct line to the point. So I might go back and try something with that. And I can't think what else I did. That I pretty much wasted a lot of my time there. So in fact, you can see here on the bag file I'm running, this was at 3:30 in the morning when I was doing this. I wasn't really looking to do a lot of extra stuff. And then by 4:30, I just gave up and said, I don't care. That's good enough for now. So I think that's pretty much all I did. Let's see, how do I get back out of here now? Let's see, stop sharing. Put this back over here. So I realize I'm going to ask for questions, but you probably were totally lost as I was saying that. So, but anyway, I'll say, yeah. Do you have any questions on that?
Well, one question I did have is, of the three values that you plotted, remind me again which is actually used in the steer angle calculation?
It would be that orange jagged line is the one that's getting used. So I don't know if that's enough to screw it up or what. Fixing that didn't seem to fix it. So that's not the total answer yet.
Hmm.
And I'm still thinking there's just some fundamental thing about what they're doing that isn't really the way it should be done. And that's what I'm trying to track down. Just see, can I find the smoking gun on what we need to do there to make that work.
Well, just to stay consistent, if you send me the code that you added to the look ahead info function or method, I mean, I'll add it to mine just so we're both capturing the same elements in that informational array.
Yeah, it's kind of merging off very quickly. So I don't know if it's gonna be obvious how to do that, or because a lot of it's just got a lot of hack and slash stuff in there too. So it might be a total mess right now.
Okay. Well, on my side, let's see, what's the best way to talk about this? This is path on the left is how it was run in simulation. On the right is how it was run in the real world. The orange line is the planned path. The green line is the executed path. Last week, I had a couple of problems that I thought would be solved by having a look ahead distance and a speed for each individual waypoint. I still think that's the case. I mean, there might be a more elegant way to fix it, but at the moment where I'm at is I've updated some programs to have a look ahead distance and speed for each individual waypoint in the, at the moment, this takes 3,000 points to execute. Some things to note. It is, cutting off that right-hand turn a little bit. There's a fix to that if I want. At the moment, when I plan a path, I just have one point from basically here to here before I run the path generator. If I put a point here and slow it down on this curve, I think that would make that curve more correct. But then on the executed path in the field test, it runs pretty straight lines here with a speed of set at 0.75 meters a second. So I can live with that level of performance, but then after it makes this Dubin's turn, it gets wavy all of a sudden. Now, that speed on this curve wasn't slowed down as much as I wanted it to be, so my next step is to actually slow it down further as it makes this curve, and I don't know if it gets set up correctly before it starts executing the straight part, whether that will take out some of the waviness or not. So yeah, still trying to tune steering in order to get the waviness out. And my next step is to slow it down further, going around that curve. Let's see. I put the link to the code. Here, which is the adjustments to pure pursuit. As a reminder, previously Pure Pursuit subscribed to a path that was generated by another program, and basically what I've done is added a load thing. Come on, why aren't you finding that? That's at the bottom. Bum, 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 bum. Receive path, that's still in there, but can come out. Oh, goodness gracious. Passed it up. Oh, I know why that's not working. It's because bum, 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 bum. Well, might be easier here. So this is the function that I've added. It basically reads in a file, which is a text file, and it breaks apart or pulls off of each of those records the X and Y and yaw plus the look ahead and speed. The X and Y and yaw, which is turned into a quaternion, is published to a path, and then I save the look ahead data and the speed values into separate arrays with the same index. And so as I march through those indexes, I pull up that look ahead speed and look ahead distance and speed from those arrays. That's one change. And then it generates this. Well, this is actually generated by the path generator, but to run that path at a step size of 0.1 meters, it's got me looking at just under 2,500 waypoints. This is what the somewhat hand-built, somewhat algorithmically built path looks like. So it takes those 23 rows and turns it into the 2,400 records. This is the program that does that path generator. So all that's out there. What I'm adjusting now is my launch file, because in my setup, I have a parameter for the servo setting based on the linear X. The servo gets a different value that controls the hydrostatic transmission, and so I'm adjusting these in order to get the speed to match what I want it to match. So more field testing required. I think that's oh, and then on the path generator, I found it a little bit easier to. So those red dots are the 23 records that I input. It just made it a little bit easier for me to sort of figure out what adjustments I wanted to make, because a couple of these needed to be moved around. And then again, it's a bit clumsy and hand built, but that's where I'm at. And what I mentioned earlier, like this curve, I can zoom in further. This curve has, I'll say, an entry point and an exit point. At the moment, these curves only have an exit point. If I put an entry point here, then I could drive a different speed on this curve, because at the moment this have to change the whole segment, as far as speed and look ahead distance goes. So anyway, that's where I'm at. Questions on any of that? Oh, and then the bag files are out on Google Drive. I had trouble updating GitHub, so I'll get that fixed and update this, but the bag files are out there as well. 2 bag files, one for simulation and one for the real field test. That's where I'm at. A little bit of progress. Still tuning.
That last thing you were just showing, could you paste that link into chat?
I can. It's this link here. You saw me put it in chat.
Yeah. And I can't see what link you're pointing to because you're not sharing, but
Oh, sorry.
And the problem is with Google Drive, it's got all these weird things that you can't, it's not obvious. It doesn't say L stuff, field testing, something. It's got these big long numbers, and somebody could painstakingly try to look at that and type all that in. On Slack, it's real easy because it says link and then points to it. But on the video, you can't see that. And it could be if we just had a link to your base stuff on Google Drive, and then it's got directories under that. Maybe that would be the easiest way to find this stuff instead of trying to take, if you take an individual page like that, it just gives you these stupid links to it that don't make any sense. Was my point.
Yeah, they're definitely not human readable. What it is pointing to, just to clarify, is in lawn tractor automation. Under field testing, there's one there for October.
So if you back up to where it said field testing, or no, what was the one said tractor automation? Click on that one. Maybe post the link to that one, and that would get people into there, and then you could navigate with the directory that at that point.
Where's chat? I put 2 links in chat. Click on the second one and see if it takes you to the headline folder.
Yes, it does. So then if I click on field testing, it should take me. Yeah, that seems to work. And I don't remember if people have to be authorized to get into your Google Drive or not. So if somebody's watching this video and wants to get in, they might have to, if they really want to see it, then they can harass you to get authorization to it, I guess. Okay, so that keeps me happy at this point, I guess.
That's where I'm at.
Oh, another comment. You said, well, I should send you the changes I made to the pure pursuit stuff, so you could add in the extra fields. Well, that's the whole stuff I was talking about, where when I switched from, and I kept calling it know-how. Is actually called Howde pure pursuit is the newer stuff. And since they did stuff differently, your function doesn't work because it's talking to different transforms or poses or whatever. So I had to do a lot of hacking to get that to work. So it's not just a drop-in thing. So that's why I say, well, I'm going to hesitate to send you that because it's a real mess right now. And that's why also when I got halfway through it, I thought I should have just taken the original stuff and just worked with that and not try to move on to this newer stuff. It would be easier to take out the few extra steps they put in the newer stuff and put it back into the old stuff, and then that would have been probably easier to deal with at that point. But that was the middle of the night, and now I'll have to think about that some more to decide where to go from there.
Yeah, you're right. I just realized that is a lot of those variables are coming out of those KDL frames that are created. I think you can turn off recording.